9, 10. Hello students, myself Rakesh Kumar Pandey. I'm going to discuss with you a very important topic of physics, that is system of particle and rigid body. It is very important topic for the purpose of NEET, GMAIN and G Advance. So we have to discuss all the important concepts, derivations and very important questions asked in GMAIN, NEET and G Advance. So we have to discuss first of all about the rigid body, because rigid body is the fundamental concept of system of particle and rigid body. So we have to understand what is rigid body. We know that a solid, we already know that solid cannot be deformed on applying external force. So we can say that a rigid body is a solid body which has no deformation. It means if we apply external force on the rigid body, then we cannot deform that body. So such type of body are called rigid body. Let us take an example of a rigid body. This is a metal cylinder. This is a metal cylinder rolling on a surface is a rigid body system. This is a metallic cylinder and it is rolling on any surface. It can be example of a rigid body, because we can say that here the position of point A and B doesn't change with rolling of the metal cylinder, and position of each and every particle with respect to the axis remains constant. Now we have to understand some more important concepts related to the rigid body. This is a rigid body. Suppose that this is a rigid body and there are 2 points on this rigid body. The first point is P and the second point is Q, and these P and Q point are making theta 1 and theta 2 angle while rotating it, and we have explained these 2 points in detail here. P and Q are 2 points, and we are dividing the component of theta 1 and theta 2 here, that is Vp cos theta 1 and Vp sin theta 1, and here Vq cos theta 2 and Vq sin theta 2. Now we have to calculate the relative velocity of Q with respect to P. From this given diagram we have to calculate relative velocity of Q with respect to P. Now QP, it means the Q is the initial position and P is the final position. So we have to calculate the relative velocity between these 2 points. So the relative velocity at point Q is Vq cos theta 2 I plus Vq cos sin theta 2 j minus Vp cos theta 1 I minus Vp sin theta 1 j. Now by solving again we can see that taking I common from both these expressions, so Vq cos theta 2, here Vq cos theta 2, and here Vp sin theta 1, Vp cos theta 1, so into I cap plus Vp sin theta 1 minus Vq sin theta 2. So we have the new expression. Since velocity of separation is 0, because we know that this is a rigid body, and when this rigid body rotates about its axis, then the velocity of separation between the point P and Q is 0, because if it is a rigid body then velocity of separation is 0. Therefore Vp cos theta 1 and Vq cos theta 2 equals to 0. So we can say that Vqp equal to Vp sin theta 1 plus Vq sin theta 2 j cap. So we can see that here the relative velocity of Vqp, we get only the horizontal components. So from this from this derivation we can say that the relative motion is perpendicular to the line joining the points. It means on a rigid body there are 2 points P and Q, then and this object is rotating about its axis, then the relative velocity of P and Q is always perpendicular to the line joining the points.